All right, a couple warm-up problems, stuff to get you ready for the AP. All right, on this one, this is simply an indefinite integral because there are no limits. We're not finding the area. We're looking for the function that this is. And we should immediately recognize it's a root function on the bottom. This is a u-substitution. With some practice, you might not even need to do the u-substitution. All right, derivative of u is du. Derivative of x squared is 2x. 3 is 0 dx. Because I really can't make the integration. So I look up the board and I see this junk is u. 2x dx is what? Du. So I can rewrite this problem, and this stuff over here, as the integral of 1 over square root of u du. You guys agree? That's equivalent. Well, go back to your algebra 2 rules. I can move this to the top and write it this way.
Why didn't you put? Like, I hate this.
All right, we'll leave it. Everybody, every time we do an antiderivative at this point, do we agree it's just add 1. Negative plus 1 is a half. Divide by the new power. Yep, moved it up. Well, no, I added 1 to a negative. Right, to integrate it. Plus c. Now, one less step. Here, I'm going to slide this down because we're going to do one more thing here. I'm going to back to the top. Everybody, now I can write this as 2u to the half. What's u? U is x squared plus 3 plus c. And a lot of times on the AP, they would take it all the way back to what? Radical form. And everybody, that is the answer. 2 times the square root of x squared plus 3 plus some constant c. Yep, flip the half, multiplied by 2 over 1 in my head, top and bottom. Yep, 1 divided by half, flip it up. Everybody, I got to ask here, how would I make this problem a little tougher? If I was to make this problem a little tougher, here's the one thing I could do. In fact, most of this wouldn't change. I could say instead of having a nice pretty 2 up there in the original problem, let's use black. What if I change that 2 to something ugly? Let's say I change it to 17. All right? Your u is the same. Your du dx is still the same. But the problem then is when you look at it, it's not just 2x dx becomes du. So this step is going to look different. First thing I would do is you pull the 17 out. Do you guys agree? Because it's constant. But I need a 2 here. I need this 2 to be with the dx. So if I want to put a 2 inside, I can, so long as I multiply by 1 overall. So I can put a 2 here, as long as I put a half out here. Because what's a half times 2? 1. What's 1 times 17? 17. So when I'm all done with this, the only difference in this problem then on the next step is that you get this coefficient in front. And what do you do with it? You just drag it along, and yeah, it's just going to be 17 on this problem. Now everybody, this is really where students freak out, but it's not that bad because you can check your last step. If you take the derivative of that stuff, you got to get the original things you started with. There is a way, all right? Again, and this all comes back to our rules of integration, all right? All right, problem 2, another short answer, kind of unrelated, but a good one to talk about before the AP and midterms and finals that are coming up. Approximate the area under y equals x cubed plus 1 from 1 to 4 using 3 intervals and a right endpoint. Guys, this is a Riemann sum. I didn't call it a Riemann sum. It is a Riemann sum. You don't have to have a graph. You absolutely positively don't. I'm going to do this by doing a table. All right? Now, everybody, hopefully you can picture the graph, but it's not that important. All right? It starts at 1, goes to 4. And obviously I have 3 intervals. Why? So 1 to 2, 2 to 3, 3 to 4, right? I made the math. There are 3 intervals. There's an interval here, here, and here. Do you guys agree? 3 intervals. How big are the intervals? They are 1 wide. I plug the values into the equation. I get 2. 2 cubed is 8, 9. 3 cubed is 27 plus 1, 28. 4 cubed is 64 plus 1 is 65. All coming from right there. And I know I did that fast, but that's the math. Now, once I have this, I want to do this as right endpoints. We know that we can approximate using a Riemann sum. We're going to approximate from 1 to 4, right? The function, which I'll just call y, dx, right? Y is x cubed plus 1. You can write that in there too, I suppose. Equals. I can approximate this as 1 times, well, what? The right endpoints. Well, the right endpoints are f of 2, f of 3, and f of 4. That's the right endpoints. If I wanted the left endpoints, you guys agree it'd be 1, 2, and 3? The midpoint would be a much bigger pain in the butt on this one, right? You guys would have to calculate 1 1/2. Well, you have to take the midpoint of 2 and 9, right, which is 11 halves. You'd have to figure them all out. We're not going to do that with this function. But on this function, the answer would be 9 plus 28 plus 65, 95 plus 7, 102 is the answer, because the sum of these three is 102 when I added them up. So the approximate area under the curve of x cubed plus 1 from 1 to 4 using 3 intervals and a right endpoint is 102. Now, I'll write this the other way, notation-wise. Think about it, guys. Is this a problem we probably could figure out right away with our calculator? Absolutely. And is a right going to be an over and under? I'm almost sure, because this is kind of, if you think about how the shape of the curve is, this is an overestimate, right? This is an overestimate. If we do this integral, we're going to find 102 is too high. All right? Keep practicing. Don't surrender.